on linked lists. So we've seen different types of collections before, and one of the collections that we built in class was array lists. One of the things that array lists can do is that they can grow, or like you can add stuff to them without worrying about how big they are, as opposed to arrays, which you have to know how big you want them to be. Array list you can add stuff to it and you can remove stuff from it, and they're completely fine, so you don't have to worry about size. Linked lists are something similar, except that they don't use arrays. Linked lists use nodes. So imagine a linked list as having different nodes, and there's always the front node or the head. You can go ahead and add things to a linked list. So you can add things to the first spot. You can do add first, and then you can add something. What happens is that you're going to create a node object, and inside that node object you're going to have some data, and that data is going to come from whatever the user gives you. So in this case, to give you the word eat, you put that string inside of the data, and then you create a node and you say there is nothing following this, it's just node, and then you go ahead and put that node on the head. If you want to add one more thing, then you can call linkedList.addFirst again, and you say, hey, I want you to store this string in here. So you create one more node, and that node will have a certain amount of data, and you want to add this node to the first item on the list. In this case, the first item is the head, so you want to add node to the head. But you also have to make sure that you are linking this current item to the next one. So you say the next one is going to be whatever is at head right now, and then you are going to make this item into the head. So now we have two things inside of our list. You can do this again. You can say, go ahead and add this string. Again, make sure that the next thing is the head, whatever it is there right now, and then make this node equal to the head itself. And if you continue to do that, you can add things onto the list, and it behaves just like an array list. You can add stuff to it, you can remove things from it, you can iterate, and it really is just used to hold stuff. So in this unit, what we're going to do is that we're going to learn how collections, specifically linked lists, and then eventually trees, hold things in different ways. What you do is you will go to the computer science website, and you're going to get lab number 4. So if you go to problem set 4 and you click on lab, then you will be able to get this link right here, and this link will ask you to join. Once you join and get your link, you grab the link that it gives you, you copy it, and you open up IntelliJ. If you don't have IntelliJ, you can go ahead and download it. It's free. You don't have to worry about paying for it. You click on get checkout version from version control. You click on Git, and then you paste the link in there, and this will go ahead and clone it. What's happening here is that I already have it, so I'm just gonna put it in a different folder. That way it doesn't get mad at me. I'm gonna put this folder outside. Oh, sorry. New folder, new lab 4, and then I'm going to click open, and I'm going to go in there. Okay, so when I clone it, it's going to ask me for a couple of things, and I'll try to make sure that I fix those. The first thing that it's going to say is you're going to need to fix your SDK. So it might ask you up here on the top right corner whether you want to change your SDK to set up SDK. You will click that, and you can pick 1.8 because you won't have 11. I have 11, but it really doesn't matter which one you pick. So you go ahead and go OK. It's going to fix some of the errors that might have been showing, and then you can go ahead and get started on the lab. If you see the lab, we have a CIS linked list. So this linked list class acts as a list, and then it has one instance variable, which is called head. That head is of type node, and that node can be found towards the bottom where it says node class. You'll notice that that node has a data instance variable and a next instance variable, just like the illustration. And if you want to create a node, you have to give it data, and you have to tell it what's next. Next is going to be of type node, so you have to give it a node object. We're going to go through the first couple just for you to familiarize with how this works. So to do number 1 says set head to null in this constructor. So head will equal to null. That means that whenever we create a new linked list, the head is just going to start as nothing, so the linked list is empty. Then we're going to check if this linked list is empty. So we're going to say return head equals null. So return true if this is true, or return false if this is false. Next, set the head to a new node containing item for the data, and the new node should point to the old head. So in this case, we're going to do add first, which I just illustrated in the presentation. So what we want to do is we want to create a new node. So node, say n1 equals new, and then we want to give it 2 parameters. One is going to be the data. So in this case is going to be item because it comes in. And then the next thing is going to be the next node. So we can just say head. To begin with, the first head is null, so you're okay. But then every other time that you add first, then you are going to get whatever was there already. It says the new node should point to the old head. It does that right there. And set the head to a new node. So we haven't done that. So then we'll go head equals n1. So now what we've done is that we created a new node. We put the items that we wanted in there. We pointed it to the old head, and then we set this new node to be the current head, which is the illustration that I had beforehand. For the following ones, you can continue to try to do them. If you have any questions, let me know.